Hi, welcome to this Blender video tutorial entitled Rigid Bodies Part 2. This is the second video tutorial in the series. If you have not viewed the first video tutorial, please do so as it contains information not covered here. To continue on with the demonstration of Blender's rigid body dynamics, I've placed a plane object in my scene. Resting on the surface of this plane object is a cube object. I will go to the Blender Scene Editor, and in the Rigid Body World panel, I'll click on the Add Rigid Body World button. This will invoke the Rigid Body Dynamic system for the entire scene. I will select the plane object, and in the Rigid Body Tools panel, make it a passive rigid body. I'll select the cube object and make it an active rigid body. I'll press the play button to run the simulation. Since the active rigid body cube is resting on the passive rigid body plane, it is not visibly affected by gravity and remains stationary throughout the simulation. I'll stop the simulation and go back to frame number 1. I'll press Shift-A and add a wind force field to the scene. I'll rotate the wind object 90 degrees around its y-axis so that its wind effect will blow from left to right across the x-axis. In the Physics Editor Force Fields panel for wind, I'll increase the wind strength to 100. It does not make any difference where the wind object is located along the x, y, or z axis. It will present an equal wind force going from the minus x direction to the positive x direction across the entire scene. However, since the wind object is located on layer 1, it will only affect the rigid body objects located on layer number 1. I'll press the play button and run the simulation. The active rigid body cube reacts to the wind force and slowly slides across the passive rigid plane and finally falls off the edge of the plane. I'll stop the simulation and go back to frame number 1. I'll select the cube object and press Shift-D and make a duplicate cube object and move it a bit along the x-axis. Notice that the duplicate cube object contains the same object data as the original cube, and it is itself an active rigid body object. I'll press the play button and run the simulation. Both cubes are affected by the wind force and slowly slide across the passive plane object and fall off the edge. I'll stop the simulation and go to frame number 1. I would like to create a situation where the first cube slides into the second cube and pushes it off the edge of the plane. To do this, the second cube needs to be an active rigid body but not affected by the wind force. To do this, I can move it to layer number 2. The wind force, being on layer number 1, will not affect a rigid body object located on layer number 2. Before I do this, I'll need to select the second cube and press the U key and select Make Single User Object, Data and Materials. I need to do this because the particular cube is a duplicate of the first cube, which was created on layer number 1. Had I gone to layer number 2 and created a new second cube there, I would not have to do this. Now I can select the second cube object, press the M key, and place it on layer number 2. I'll then add layer number 2 to the scene. I will now press the play button and run the simulation. Notice that even though the second cube is on layer number 2 and the wind force object is on layer number 1, it appears that the wind force has an effect upon the second cube object. This points to one of the many idiosyncrasies of Blender's physics systems. Notice that in the timeline editor that there is a green line running the length of the simulation. This indicates that Blender has created a temporary cache of the data for this simulation. Now normally this temporary cache is reset each time the simulation is run. However, sometimes, and for reasons I do not understand, The temporary cache is not rebuilt and Blender replays the existing cache of the simulation data. This is the case here. To work around this problem, I'll select the second cube and click on the Remove button in the Rigid Body Tools panel on the left. This will remove the second cube object from the Rigid Body world and reset the cache. I'll then click the Add Active button and return it to the scene's Rigid Body world as an active object. I will then press the Play button and run the simulation. Note that the second cube is no longer affected by the wind force because it is located on a different layer. Also note that the first cube collides with the second cube and slowly attempts, unsuccessfully, to force it to the edge of the plane. I'll stop the simulation and go back to frame number 1. I'll select the wind object and increase its strength to 300. And then play the simulation. The wind now provides enough force on the first cube to allow it to move the second cube off the plane. I'll stop the simulation and go back to frame number 1. Both of the cubes have the same default mass setting of 1.0. I'll select the second cube and change its mass to 5. And then play the simulation. The first cube no longer has the wind force to move the second cube off the plane. I'll stop the simulation and go back to frame number 1. I'll select the second cube and delete it. I'll then turn on layer 6. Here I have modeled a stack of 15 cylinder objects. I will go to Front View, Numpad 1 to select the objects. However, another Blender idiosyncrasy is happening here. They seem to crop up a lot when working with rigid bodies and layers. Note that the Rigid Body Tool panel controls are all grayed out. I will select the cube object, and now I can box select all of the cylinder objects. And in the Rigid Body Tool panel on the left, I'll click the Add Active button, which will add all the cylinder objects to the scene's rigid body world as active objects. I'll now play the simulation. The cube object, forced along by the wind, collides with the cylinder objects and makes them tumble to the ground. I'll stop the simulation and go back to frame number 1. Another way to increase the effect of the cube object on the cylinders, besides increasing the wind strength, is to lower its friction setting and increase its mass setting. I will select the cube object and in its Physics Rigid Body Collision panel, set the friction setting to 0 and the mass setting to 3. I'll then play the simulation. With less friction and more mass, the cube has a larger collision impact on the cylinder objects. I'll stop the simulation and go back to frame number 1. For the time being, I will turn off layer 6, which contains the 15 cylinder objects. I'll then select the cube object and snap my 3D cursor to the cube, Shift S, so it is located in the same position. I'll then delete both the cube object and the wind object. I'll then press Shift A and add a cone object to the scene. I'll rotate the cone 90 degrees around the y-axis. And for clarity, I'll make it smooth. Then in the Rigid Body Tools panel on the left, I'll add the cone to the rigid body world as an active element. In addition to being affected by external forces and collisions, rigid body objects can also be animated. In the Physics Rigid Body panel for the cone object, I'll check mark Animated. I will then add layer 6 back to the scene. I'll select the cone object, and with the animation timeline set to frame number 1, I'll press the I key and insert a location keyframe for the active rigid body cone object on frame number 1. I'll then go to frame number 50, and I'll move the cone object past the cylinders along the x-axis. I'll then press the I key and insert a location keyframe for the cone object on frame number 50. I'll then reset the timeline back to frame number 1. And now play the animation simulation. Now the animated active rigid body cone object moves along the x-axis as animated and collides with the cylinder objects, making them tumble to the ground. Another useful feature found in Blender's rigid body dynamics is the ability to create rigid body collision groups. By default, when an object is added as an active or passive element, it is automatically assigned to rigid body collision group number 1. We can see this in the Physics Rigid Body Collisions panel. Assigning different elements to different collision groups allows modelers finer control over how rigid body objects interact with one another. Here the cone and all of the cylinder objects are part of the default rigid body collision group number 1. I'll select the cone object and press Shift-S and snap my 3D cursor to its location. I'll then press Shift-A and add a UV sphere object to the scene. I'll scale it down a bit, and I'll move it back behind the cone object along the x-axis. And for clarity, I'll smooth the object. I'll then press the Add Active button in the Rigid Body Tools panel and add the sphere to the scene's rigid body world. Note in the Physics Rigid Body Collisions panel that the sphere has been added to the default collision group number 1. I'll change this to collision group number 2 by clicking on the second collision group box. I'll then add layer 7 to the scene. Here I have modeled another set of 15 stacked cylinders. I'll go to Front View, Numpad 1, and box select this group of cylinder objects. I'll then click on the Add Active button in the Rigid Body Tool panel, which will add the cylinder objects to the scene's rigid body world. Note that all of these cylinder objects are part of the default collision group 1. Unfortunately, I cannot select the cylinders as a group and assign them to the second collision group. This has to be done one by one. I will select and add each cylinder to collision group 2. Now all of the second set of cylinders and the sphere are part of collision group number 2. The first set of cylinders and the cone are part of collision group number 1. The passive plane object is part of collision group number 1. With the plane object selected, I'll hold down my Shift key and click in the collision group number 2 box, making the plane part of both collision group number 1 and collision group number 2. Otherwise, the second group of cylinders would fall through the plane because of gravity. Then, making sure that I'm on frame number 1, I'll select the sphere object. First, I will checkmark the animated checkbox in the sphere's Physics Rigid Body panel. I'll then press the I key and add a location keyframe for the sphere on frame number 1. I'll then move the timeline to frame number 50. I'll press the I key and insert another location keyframe for the sphere on frame 50. I want the sphere to remain in this location for the first 50 frames. I'll then go to frame 100. I'll move the sphere along the x-axis to the right. I'll then press the I key and insert another keyframe for the sphere on frame 100. I'll then go back to frame number 1 and play the animation simulation. The cone object moves along the x-axis in 50 frames and collides with the first group of cylinders and topples them over. Neither the cone object nor the first group of cylinders affects the second set of cylinders because they belong to a different collision group. The sphere moves along the z-axis from frame 50 to 100 and collides with the second set of cylinders and topples them over. Using collision groups is a good method for controlling rigid body simulations.